So yeah, before I start, just a quick introduction. So my name is Himanshu Chatpar. I was working as a software developer for I'm still working as a software developer for around 1.5 years. I've experience in React, React Native, TypeScript, GraphQL, as well as Node on the backend and Postgres too. So I started learning React Native when I joined my first job. So I was actually hired as a React developer, and then I transitioned to React Native as well. So that's how I got started with it. So yeah, a bit of an introduction to React Native would be uh, to develop mobile applications. We usually use React Native. So React Native is not just limited to mobile applications. You can also build TV, web, and other applications as well. But it's usually used for iOS and Android only. Uh, and why are we using React Native? Well, you can share code, like you write code once and you share that for Android as well as iOS. So prototyping is pretty quick in React Native. So usually startups prefer React Native over Android and iOS native, because you would have to hire engineers for Android as well as iOS. But with React Native, you can share the same code base and build the app, like by hiring a single React Native developer. And React Native is pretty similar to React. You can pick it up very quickly. So yeah, that is like the introduction on React Native. So yeah, let's start. Uh, yeah. So I would like to share my screen. Okay. Is my screen visible now?
Yes, it's visible.
Okay. So again, this is just the introduction. So prerequisites, like what I expect you to know so that you can follow along. So the first thing you need to know is first thing you need to know is CSS. Like you need to have an idea of how Flexbox works, as well as positioning. So position, as you know, is static, absolute, relative, and so on. So that is something you should know. Like that is the bare minimum CSS you need. Apart from that, you need to know React and JavaScript, otherwise you won't be able to follow through. um, the outcome, this is like the first in a series. Like I'm looking for a series, so this would be the first part of it. So the outcome I'm looking for is you would be able to develop mobile applications using React Native. And along with that, I want to cover the common interview question as well as the architecture, so you understand how React Native works. So this is like the outcome which I'm going for. Okay. So, the way I've structured is, first I would like to code, and then I'll explain how React Native works. So we'll cover the architecture and everything today, but I'll show that after I give you a basic idea of how the code works. Right. So the easiest way to get started with React Native is like just go to Expo Snack. Right. So you can go to the Expo Snack. This is the website. You can go here. Okay. So here you can see there are multiple options: web, Android, iOS. So I'll just go for Android. Tap to play. So it will load everything for you. So this is how you can get started with Expo without getting into the setup. So with React Native, one thing you need to know is the setup is usually the hardest part. So like the setup is hell, but the coding part is very very simple, and very similar to how you code React apps. So yeah, before making any changes here, this is like how you can start. So there are effectively two changes. So like in when we develop web application, we use stuff like div, p, button, right? So there are analogous stuff in React Native. So div becomes a view. So instead of a div component, you would use a view component. Instead of using p, you would use text. Instead of using a button with a small b, you would use a button with a capital B. Uh, to make anything clickable, you use touchable opacity or pressable. So these are two options. So before pressable was there. So pressable is the newly introduced uh, component. So before that, touchable opacity was there. So this basically gives you a bit of animation along with the pressable uh, functionality. But you can use any of these. These effectively act as the same thing. Just touchable opacity has some animations, and on click comes on press. So like minor differences, but overall the logic remains the same, right? So the like when you start React, you basically start with a counter, right? So let's just start with a counter, right? Okay. Before that, one last thing, like before going into the code, one last thing I would like to discuss is the styling. Styles are written with the help of style sheet. So style sheet is basically given to us by React Native, and you create your style objects like whenever you write native React code. So what you do is style equals to some object, some style object, right? So you just write that style object in style sheet. Why are we writing this style object in style sheet? Basically, it creates a stable reference for the style object so that on every render it does not update and reduces data transfer over the bridge. This is something I'll explain later on. But basically, for performance reasons, you can say we are using style sheet. Okay. Now, this is the basic style sheet. Now, what changes in CSS is basically Flexbox is the default display and the default direction is column. So, your mobile app is vertical, right? So, that's why the default display is column instead of row. So, and by default, Flexbox is enabled. Now, position, there are only two positions in React Native, relative and absolute. And that's like the pretty much the only difference. Apart from that, you can use everything you would know in React in web with some minor changes. So you can use stuff like transform, translate. That is also that can also be used to add shadow and stuff like that. You use elevation. So there are minor differences, but most of the logic of CSS you can carry forward to React Native as well. So up till here, do you have any questions, or should I start with the code? Can you please explain about React Native and Flutter? Okay, so basically Flutter and React Native, the difference is React Native we use native components that are provided by the OS. So basically in Android you use the components that are in Java, Kotlin, and for iOS you use components that are in basically given by Swift and Objective C. So you use the native components that are actually provided by the underlying OS. So that is how React Native is working. But in Flutter, what you have is basically a Flutter engine. So that Flutter engine basically implements the button, the text, the view, everything that is implemented by the Flutter engine. So Flutter is basically an abstraction over everything. So when you run Flutter code, you actually download a Flutter engine which uh, talks with the native code. In React Native, you use JavaScript and directly talk with the native code. So that's the major difference architecture wise. Yeah. So Expo and React Native is something I'll explain later on. So it is there in the slides. This is something I'll cover later on. Anything else do you want to know about Flutter or React Native? Any key point you would like to know? Okay, so I'll start with the code. Mm, yeah, so I'll start with the code. Okay, and this it logged us out. Okay, so I'll get rid of everything. Like we don't need this. Like we don't need this. Like we can get rid of a lot of stuff over here. Um, okay. This is safe area view, so you can actually substitute it with view. This won't be an issue. Safe area view basically saves the view from getting from touching the notches and stuff like that. So for now, you can just use view. Yeah. So view, and I'll get rid of the style sheet for now. Okay. So this is like how you create a style sheet. So you have styles object that is created by style sheet, and now here you add your style. So I have a view component. So view, I have what I have is styles.container. So I'll add a container here, right? So now here I can have all the CSS associated with it. So I have width. Let's add 100. Let's add a height of 100, right? And let's set the background color to maybe red. Oh, sorry. Okay. Yeah. So you can see this is where it's coming from. You have stuff like margin, uh, top, and stuff like that. So margin top maybe 10, so that you can see it came a bit down. So you can see this component that we built is basically overlapping with the status bar, right? So this is the status bar is what it's doing. So you actually can get the status bar from here. So you can get that too, and you can create a normal like JSX fragment to here. It's the same thing. You can add a status bar here, and then you can, yeah. So you can see we have status bar. We can change the color and stuff like that. We can get the height of status bar and then make sure like the view we are rendering renders after the status bar. So you can get like there are native status bar dot height and stuff like that. So you can do that too. Like for now, I'll just make sure the margin is like good enough so that it doesn't obstruct. But yeah, you can do stuff like that too. Okay, so this is like the basic uh, div equivalent of what do you say, in React Native, how you would make a div. In web, how you would make a div is like this. In React Native, you just substitute the view and add styles in such a way. Okay, so do you have any doubts over here? Okay, so I'll start with the counter. So that is like the most basic version. So again, it's the same thing. You can just use use state and stuff like that. So count, set count. You can get that from use state. Sorry, use state, and that will be 0. So I need to import use state from React. So import use state from React. Okay. So this is something you can do. Right. So now it's not giving an error. Now, okay, I'll show you one thing. If I render the count over here, like directly, this will give an error. Okay. So you can see text strings must be rendered within a text component. Like I'm not sure how visible this is, but you can see here text component must be rendered within a text component. So basically, the web is very forgiving. It allows you to basically put up direct text into the div node, right? So React Native is not so forgiving. You need to add a text component. So you basically just wrap this inside a text. That's it. That is what this is saying, right? So you can see now I have 0 over here, right? Now the other thing what you would do in a web platform would be you would add a on click over here, right? So you can see there is no on click, there is no on press over here, there is nothing. Like you don't have this stuff on a view. So how do you add touchable, like how do you respond to events? So you can do that through touchable opacity or pressable, right? So I'll use touchable opacity. Touchable opacity. So this is the component. So you can wrap this over anything. So touchable opacity, it can wrap over view and stuff like that. Touchable opacity, right? So I'll wrap this, Control X and V. Yeah. Okay. So this is now touchable. So you can see this flickers, right? So basically, you can see some touch is happening. Now I can add a on press over here. On press. So basically, this is just normal React now. So you create a function handle click, and you basically do this console.log I was clicked, right? Handle click, right? So how do I get the logs? Okay. Mhm. Okay, I'm not sure how do I get the logs over here, but let's just set state. Um, sorry, set count. I'll just make sure the count becomes count plus one. Right. Okay. So one. Now I clicked again. Two, three. Right. So you can see this count is updating. I'll just zoom in a bit. So you can see this is four, five. Right. Okay. This is like standard React. It's nothing different. Just we use the touchable opacity to wrap over the view, and we added a handle click so you can update the count. Okay. One more thing. What I can do is I can center this. Right. So I was saying this is by default is flexbox, and by default it is column. Right. So I'll just justify content to center. Right. So you can see it centers vertically. So you can see this is a flex box, but default direction is column. One more thing I can do is align item center. Align items center. So it basically centers properly. Right. Now I can style the text too. So I'll add a text style over here. And over here I'll just add font size, maybe some 32. Okay. Um, okay, a new style. So nothing to worry about. So I'll just style is styles dot textile. Yeah. So you can see this size is now bigger. So I can actually make it a bit bigger, and font weight I'll add maybe some 700. Right. So this is now bold and basically big. So all your CSS basically works. So instead of shadow, you would use elevation. So elevation maybe 10 or something like that. So five. This basically gives you shadow and effects like those, right? So everything else is same, just minor differences. Uh, uh, yeah. Any doubts till now? Use console.want to okay to display. Okay. I think this is pretty clear. Any questions over here? Can't we use external style sheet? So, what can you just explain what do you mean by external style sheets? Like, uh, so you're saying basically, okay, everything is in pixel. There is no REM. Everything is PX. Yeah, you can use Tailwind, but you would have to basically set that up. You can't directly use Tailwind, so there is some different setup. You can do that, but I'm not going to do that. We'll basically eat up all our time, right? External style sheet, if you're saying we can move this styles into a separate file, yes, we can. That won't be an issue. Like class name we use in React. Yeah, so basically you can use Tailwind, but like normal class name, I don't think you can use. So this is like the standard way of doing. Basically, either you use CSS style sheet. Sorry, CSS and JS, you use either you use that or you use these styles. That is like what we do in React Native. You don't directly, you can't have inline styles like what you have in React. That is not possible. To use inline styles, like this is the proper way. Okay. I think you can also do this, like inline styles. If you do this, this would work, but it has implications. Like you can do this instead of doing this. You basically do this. This would also work. Like if I do it blue, this would work. Yeah, you can see this works, but basically on every render, this is created. This is passed over a bridge, and then it is reused again. So this basically has performance implications. So you don't use it like so. You use it like this. Okay, and one more thing, you can have multiple styles in an array. So you can add an array and have multiple styles over here. So container two, maybe if I can container two, maybe I'll just add background colors to blue, and I can add styles dot container two. Yeah, you can see. So you can have multiple styles in an array. You do not need to merge it manually. So this is applicable to text as well. It is not just you suppose this, you can add this anywhere, right? So this is like all the practical part wanted to show. So you can now go and build some cards and stuff like that, because that is something you can look through tutorials and stuff like that. That is like the easy part. I've given you the overview so that now you can make UI. Now, actually, I would like to discuss stuff that is not there in most of the tutorials, or it's lacking. So, how do you make text elements? Okay, to make the text elements clickable, you can wrap them in touchable opacity or pressable, like what I have done here, right? So instead of wrapping this whole view, you wrap the text in this. So like so. So now the text would be clickable instead of the whole view. Right. So you can see this is not clickable, but I think text is clickable. Yeah. See, not clickable, clickable. Yeah. So that's it. Uh, is applicable only on views, not on buttons. Buttons come with your inbuilt on press listener. So if you use the native button like so, so the button comes with its own, sorry, button. So you can basically add a title like hello, and it comes with an on press handle click. So button works. Okay, sorry, title text. Okay, I think okay. Environment title prop of button must be a string. I think this is lagging a bit or something. Title was a string. Text must be rendered. Texting must be rendered within a text components. I'm not sure why a button is not working. Maybe some prop or some issue. But yeah, you don't usually use button like this. I'll just go to React Native docs. React Native docs button on press. Hmm. Let's just copy this and see. I don't think you can render text like that then. And instead of on press mode, we'll just use handle click. Okay, I'm not sure why this is not working. This should work. But yeah, you don't usually use buttons. You create your own button through touchable opacity and uh, basically text view stuff like that. Because this button is basically a default button that is given by the Android or iOS. So you can see in Android it'll be blue, but if you use iOS, this would be something like the iOS that provides. So you won't use default elements that it provides. So if I'm looking in the iOS version now, you can see this is like the native iOS button. You can update colors and stuff like that, but yeah, you pretty much don't use stuff like this usually. And why do I think it's not working? Maybe some issue with the Expo version and the React Native version. Maybe this is some old Expo snack and this is the new docs or something like that. Yeah, maybe something like that. Not sure. Uh, like yeah, you can use multiple views. You can nest views. Not an issue. Does it mean each time you need touchable as a wrapper if you want to add events? Yeah, you need to use touchable as a wrapper to make it responsive. Basically, you have something like use window dimensions hook over here. So you get the window dimensions. Let me just get rid of this button. Okay, so you can get the dimensions with use window dimensions. Yeah. So basically, you can get the width height from use window dimensions and console.one. Someone said this would work with height, stuff like that. Yeah. Okay. So basically, this is how you can uh, use your basically this is how you can make it responsive. So instead of rendering this text, I'll also render this text width and height. Sorry, width and height. Sorry, width and height as well. Okay, so I think okay, you can use percents too. Like so. Yeah, you can use percentage as well. Sorry, I forgot. Yeah, so this is how you can. So this is the width. This is the height. So according to this, you can basically uh, what do you say? Make your code responsive. Um, yeah, you can use React DevTools, but that is a different way to set it up. So I don't think it directly works in Expo Snack. The only reason I'm using Expo Slack is because this is like the easiest way to set up. I never use this. That's why I don't know much about this. But to set up local dev tools, yes, you can do that too. If you use Expo Go, you basically get a debugger attached along with it. So yeah, I think we can continue now. Like these are all doubts I would address later on as well. So before like starting every like the in-depth discussion, I would like to basically give a terminology refresher. So like just let me know if my slide is visible. It's visible, right? Yeah, I just said right. You can make it responsive by using this use window dimensions. You get the width and height. So according to width and height, you can basically conditionally use the width and height over here. So instead of doing this, you would use something like this object over here. So if basically the width you get is less than 100 pixels or something like that, so maybe do something do something else. So basically, this is how you can use responsiveness in these apps. So this hook is called use window dimensions. This hook. Okay. I need. Yeah, you need Mac for iOS apps. You can't develop iOS apps in Windows. That's an issue. Okay. So basically, DOM is the object representation of web page. So this is like the standard HTML has head and body. Head has the children, meta, link, title. Body has children, p, div, strong, and so on. So this is like the basic DOM representation of the tree. It provides an API to control the web page. So you can basically target stuff like p and update this programmatically through JS. So this is your DOM, right? This is something I expect you to know. Okay, React. You have been using React, but this is basically from basically I'll distill it down further. So what exactly is React and what exactly is React DOM is something I would like to clear. So React in itself is basically a J library for building UI, right? So it is just the idea of painting screens only when UI updates. So when some state update occurs or something happens, you need to paint the screen again. So this idea is React, right? Idea of painting screen only when UI updates. Correct. So React in itself, it handles diffing. So diffing is something when you get the old tree and the new tree. Basically in VDOM, virtual DOM, you get the new tree and you get the old tree and you compare them and see what's the difference between them. This is done with the help of diffing algorithm. Once you know what's the difference between them, you basically reconciliation happens in which you figure out the minimum number of steps that are needed to go from the old version to the new version. So basically, this is how React works. So it handles reconciliation for you, which is the minimum amount of steps needed to go from the old tree to new tree, so that the user always sees the updated version. Like user doesn't get the stale tree. So this is what React does. It basically handles reconciliation for you. So this is the main idea of the React. You paint only when some node is updated and it needs to get painted. You don't paint the whole tree again. You basically use surgical precision and update only what is needed, nothing less, nothing more. Okay, so this is React. And now what is React DOM? So before, React and React DOM were coupled. So what React DOM is, it is basically a library responsible for painting React components to the DOM. So React figures out what's the difference and what needs to be done. The implementation part of that, the actual painting on the screen, is done by React DOM, right? So React DOM is the library that binds the idea of React to the web. So before, React and React DOM were same. So these ideas were coupled. But when stuff like React Native started popping up, people realized this idea of reconciliation, diffing, and basically React, when some state changes, you need to trigger a re-render and stuff like that. That doesn't need it. That doesn't need to be bound to React to the web, right? So people, the maintainers, then extracted it into two separate libraries. So React, it handles all the reconciliation stuff. React DOM, it handles all the painting stuff to the web. So this is the idea of React DOM. Now what React Native is, it basically is the library that binds the idea of React to the mobile world. So we love the idea of React, like we just need to update the screen when something changes. So to bring that idea to the mobile world, you use React Native. So it allows us to build Android, iOS, and web applications with the same code base. So React Native is not limited to Android and iOS, although it is mostly used for that. Okay. So this is basically React Native. So any questions until now? Do we need Yeah, you need to know React.js. I heard if I heard if it will help you if yeah, you need to know React to basically understand React Native. You can actually start with React Native, but I would recommend React is easier than React Native. Okay. Okay, let's go on. So I'll. Someone was asking about Expo. So this is like the explanation over here. So React Native in itself is complicated to set up. Like I'm just talking about the setup. Setup is like the worst part of the React Native, right? So that setup part is what Expo aims to simplify. So tool for simplifying React Native configuration and setup. Like this is effectively what Expo is. So what it does is in React Native, you may need to update Java code, some Objective C code, install Coca pods and stuff like that. Use Gradle to assemble, build, and like it's a different way to run code as well as build code. Like build code, I am saying is when you build APKs, IPAs, and stuff like that. So it's a different way to build. So Expo comes in and says, like, let me simplify all of this for you. So Expo takes up the pain of setting code up, running it, building APKs, AABs, IPAs, IPKs, and stuff like that. So this is what Expo does for us. Right? It is basically a toolkit to streamline React Native. Now, one usual question that comes up is if I learn Expo, will I be able to learn React Native? I'm saying yes, it's effectively the same thing. The only difference between Expo and React Native is how you're installing libraries and how you're running code. That's it. The logic carries forward. Like if you know how to code in Expo, you know how to code in React Native, but you don't know how to run those application and build application using React Native. That's the only difference, and you can learn that in, I guess, within a week. Like it isn't that hard. Once you know Expo, you know how to code in React Native. That's like the important thing. After that, it's just setup, configuration, and stuff like that. It's just one-time stuff. You need to set up Java parts and stuff like that. So yeah. So as developers, it helps us avoid touching Java, iOS code during library installations and stuff like that. So this is the main selling point of Expo, right? Okay. One more slide I would like to cover is like Expo and React Native. Okay. Before, Expo was not as good as React Native. Like it had some issues in which you can't add certain libraries, you can't basically add certain packages and stuff like that. So that was there in old Expo. Now the current version of Expo is as good as React Native. Like you can install third-party library packages and stuff like that very easily, right? So this is like the current version. So Expo at its current state is almost as powerful as React Native. Previously, in Expo managed projects, we could not add certain libraries. This issue is now solved with the help of plugins and EAS. So, for example, like if you need to add payment system with the help of Razorpay, right? So you need to add the Razorpay library SDK. Now that was an issue in Expo, like before EAS and stuff like that. So that was not possible. So what option you had was you need to eject from an Expo managed project to a React Native project and then add the library. So basically, this is Expo. You eject out, then run it as a bare React Native project, and then you add the library. So this is how you do. And once you're ejected out of Expo, you basically uh, you basically manage Java iOS code through uh, React Native only. And okay, by manage I mean you don't write Java code, you don't write iOS code, you just add certain lines here and there that the library says you do. So library comes with the documentation. You need to add so and so line in so and so place. So that's basically just copy paste stuff like that. So that is the extent of what Java iOS you would write in a React Native project. You don't actually go and write all the Java code. Okay, usually Expo projects are once set up with Expo and then ejected out. So you would see a lot of projects that are set up with Expo because that setup is easier with Expo and then they eject out. So that's why you see most of the projects are now bare React Native because before Expo didn't have the ability to scale. Like you couldn't add libraries. Now it's not an issue. Now you can. Like in my previous company, we did add Razorpay libraries in the Expo Managed project itself. So you can do that now. Okay. Okay. Here, I would like to stop and ask any doubts over here. What is widely used? Okay. So, widely, what is used is React Native. So, if you can learn React Native, the bare version, not the Expo version, then that would be better. But to get started, what I feel is Expo is easier. I myself have started with Expo, and we actually scaled with Expo. So scaling now is not an issue, but majority of the jobs are there in their React Native, so they don't use Expo. To learn, I feel Expo is easier. So once you learn, you feel comfortable with basic UI, and you know how you can squeeze performance from Expo projects. You can then shift to React Native. Only the build system and how you run code would would differ. That's it. Okay, how easy or difficult it is move from Expo to native CLI. So here it's like a question like if you're a company that's moving from Expo to native CLI, I have no idea, right? That is something that I haven't done. But if you're asking as a developer, ki, if I know Expo and I want to start a project in React Native CLI, how difficult is it? It's not very difficult. It's a one time setup of Java paths and basically downloading emulator, downloading SDK tools, and stuff like that. So it's just basically one time pain of making sure everything is set up. After that, it's the same. Just when you add libraries, you may have to do 2 3 steps extra. That's it. Okay. I think those are this pretty much clears all the doubts on Expo and React Native, right? Okay, so when you start an Expo project like or React Native project, these are 2 3 things that you basically see. So there is something called as Metro. Metro is your bundler, like Webpack bundler. What we have on the web, that is effectively what Metro is for the React Native. So it is basically a JS bundler that takes JS code from multiple files and combines them into a single source file. Why are we using Metro? Because it is optimized for React Native. That's it. It's the same thing as Webpack, nothing different. Babel, it's basically transfer. This is a transpiler that is used by Metro. Okay, and this is something that is new, maybe a bit. So Watchman basically it is a tool that watches your source files and rebuilds JS code and pushes code to device. So what it does is it basically watches your source folder and see if something updates. If something updates, it triggers a hot module reload and make sure your device, the either the emulator that you're running on or the actual physical device that you have connected through USB and stuff like that, that is in sync with what your code is. So it basically does hot module reload for you. Okay. Some more terminology. So native compute, what I mean by native compute is the compute that is performed by the underlying OS. Okay, so that would be Java in case of Android, Objective C, yeah, Swift in case of iOS. So you can think of Java Kotlin because both of them work for Android, and Objective C, Swift both work in case of iOS. So any compute that is done by them is basically what we refer to as native. So you would hear native a lot. So this is what we mean by native. Anything that is done by the underlying OS. Uh, OS preferred languages basically Java or Swift, something like that. Yeah, this is basically all related to operating system only. You should know what a process and thread is before you jump into the architecture. So now I'm basically going towards the architecture. So process is basically any program that is being run and it has a memory associated with it. So by memory I mean RAM. Okay, so when process is run, it takes up some memory in the RAM. So this is what the memory I'm talking about. Okay, so thread. So like there are a lot of definition of threads. So mm, uh, what I understand, like what works best for me is threads are basically instructions that operate on memory. So as you can see, the process has a memory associated, right? So in this process, you can have multiple threads running on it. So all these threads are basically units of compute that work on the same memory. So multiple threads can access the same memory. Hence, they are called lightweight processes. So you can hear these threads are lightweight processes and stuff like that. So basically, in process, you have some memory and at least one thread associated with it. So thread is basically your instruction flow. So basically, this is the memory. You do this, do that, do that. So that is what thread says. Basically, instructions, right? And the same space, like same memory, can have multiple threads on it. So that is not an issue. So this is what we meant by thread and process. Process needs to have a memory and a single thread, at least a single thread. Now thread is basically just the order of compute. So what you need to do. So that is thread instructions. Yeah. So is installing Android mandatory for if you're using Expo, you do not need Android Studio. If you're using Bare React Native, you need Android Studio. Yeah. So is this point clear? So can we move towards the architecture? React Native. If you're familiar with the web, Next would be simpler. But again, Next has some basically it has stuff like server side rendering and partial hydration and stuff like that. So that is something new. React Native, like the code is very similar, just the JSX changes. Like the only part that changes is JSX. Apart from that, it's same. So yeah, you can pick any one of them. Like both have different challenges. But if you know React, it's easy. If whether you learn Next or React Native, both are pretty easy if you know React well. Okay. Let's start with the architecture now. So this is like the most important interview concept on React Native. Like there are three things in React Native interviews is what people need to know. You need to know the architecture on how React Native runs. The second thing you need to know is flatless scroll view and stuff like that. I haven't covered that yet. So if I take a second lecture, I'll cover that. These are basically performance tools in React Native. So that is like the second most important thing. Uh, and the third most important thing is you need to know about navigation. The navigation in React Native is different. So I'm planning on covering them in the maybe a third or fourth lecture. We'll see what based on what the feedback is. So if you are going in an interview, this architecture, like it is a 90% chance you will get at least a single question on architecture. Okay. So before starting that, just let me know everything is clear up till now. No, you don't code in Java, you code in JavaScript like I showed over here, right? This is just JavaScript. Okay. So let's start with the architecture. So, okay. These are certain facts or certain things that you need to know. So painting on a device is always faster with native code. Like it makes sense, right? Java, Kotlin are optimized for Android operating system. So obviously, if you paint something using JavaScript versus paint them using native code would obviously be faster, right? So that's why. Oh, sorry. Yeah, that's why painting is always done through them. So again, render and painting are different concepts. So render is a React concept. You basically run the code again, create a new tree, and see what the difference is. That is render. Painting is actually going to the UI and updating the pixels. That is what I mean by painting, right? So this is one thing. I think this makes sense, right? Painting on device is obviously faster with device specific. code. The other thing is JS code needs an engine to run it. So basically, JS obviously needs an environment, correct? So on the backend, you have code. Uh, you on the web, you have basically the browser that provides the environment. On React Native, in the recent versions, we use Hermes. Before that, we basically iOS had its own built-in engine. Android was shipped with something like I'm not sure, but in the modern versions, you use Hermes as its engine, right? So Hermes provides the environment where JS code runs. Why Hermes? Again, the same answer. It is optimized for React Native. Okay. So now let's get into the architecture. So since painting is always faster on the native side, right? So whenever we paint from the native side. So that's why you have a native thread. This is the thread to paint the UI. Then you have a shadow thread. Okay, what is the shadow thread? Like I said, we write code in Flexbox in React Native, right? So like you can see, I add Flexbox. Then I use position. I can use position absolute relative. But these are all web concepts, right? So you need someone to convert these web concepts into your native concepts, right? What the native code understands, like where exactly should I position this element, right? So that is done by the shadow thread. This is the yoga engine to convert CSS like styles, basically Flexbox to positioning in native UI. So this basically computes, like if you say position, sorry, you say justify content center. Okay, but that center means at what pixel where. That is the compute that is done by shadow thread. And then there is this third thread that is the JS thread. So this thread is to run React. It comes with your render, diffing, reconciliation, and stuff like that. So this is the main thread that runs our business logic. So you fetch basically data on the server through this thread. You run computes and stuff like that over here. Right. So these are your three threads that are actually running in your React Native. So again, I'll just summarize: native thread for painting, shadow thread effectively converts CSS to native styles, and JS thread is where React runs. Okay. So now, after I think React Native point 0.69, the new architecture takes is what's being rolled out. But I think once you get an idea of the old architecture, you can basically look at how the new architecture works. So that's why I'm covering the old architecture as well. Also, many companies just ask the old architecture only, so they don't care about the new one. So yeah, that's why I'm covering this, and basically it serves a good starting point to explore what the new architecture is. Okay, so what the old architecture was, it uses a bridge model. So as you can see, we had like three threads, right? A native thread, shadow thread, and then you had your JS thread, right? So how do you talk from JS to native, right? If you want to send some data, what you do is you use a bridge, right? This bridge is basically used to pass data between threads, and this bridge is asynchronous, right? So the data is serialized and deserialized as JSON. So that's how you pass data. So this may cause slowdowns and occasional stutters. So like if you have a long list, and then you're keep on scrolling. So after some time you may see a blank screen or stuff like that. So this occurs because of the serialization, deserialization, and stuff like that. Right. So this was an old issue. This is pretty much resolved in the new versions. But yeah, so this is like the architecture. So React, you have this JS engine. So this is effectively the Hermes now, Hermes engine, and this talks with the bridge. So you basically JSON serialize this uh, and send it to the bridge. When you're reading, you deserialize it, and this bridge you can communicate it with the native module, so native UI thread, and this actually uses shadow thread to get make sure like the layout is correct. So this is like the whole architecture. Okay. So one last thing So let's look at an example, like we use touchable opacity, right? And the user clicked a button and then we updated state. So how would that work is basically this. So the event is captured natively. So the touchable opacity, on press, everything that is handled natively. So in our case, we were running Android. So the Android would get to know, hey, user clicked this, right? So once Android knows it, it passes it to Java, and basically they serialize the message. So it says ki, hey, this button was clicked, serialize it as JSON, and send all the relevant data in the async bridge. Now you have this data on the bridge. So JS deserializes message and executes the required code. So once you have that data in the bridge, JavaScript reads that data, deserializes the message, and updates state. You can see, right, when we clicked, the state was updated. So it deserialized that message, set the state, updated it. Right now, when you update that state, basically reconciliation happens and React figures out, hey, you need to update the UI too. Like you need to paint on the screen. So JS serializes the message again, ki, hey, I need to paint this, and sends it to the async bridge. And then async, once it is passed back to the native world, so native world sees like, hey, it needs to paint the screen, so then it goes and paints the screen, right? Okay, so this is like the old architecture. So any questions up till now, like anything you would like to ask? Is it too complicated? Okay, so the last part, like the new architecture, I haven't explained much because like in this, what we do is basically instead of using the bridge, like we can see like this bridge model, right? You basically burn this bridge. You don't use these bridges, right? Because a lot of time is being wasted in serialization, deserialization, and stuff like that. So you don't use this. So what you use is called JSI. So JSI is JavaScript interface. So with the help of C++, we object native Java Objective C objects to JS. Like Java Objective C have objects, right, in memory somewhere. So C++ is being used so that you can expose these objects to JS. Now JS stores them as reference to these objects and calls them when needed. So JS now has direct access to Java and Objective C objects. That's it. So this is like a brief on how new architecture works. Like you can go into a lot of depth. It uses Fabric runtime and like stuff like that. It uses Fabric for the UI rendering and stuff like that. So you can go in depth, but I think this is like a good enough model, like how we are eliminating bridge. Basically use the objects that are stored natively and expose them to JavaScript. So JavaScript can basically directly communicate with them instead of using a bridge. So yeah, this is like how the new architecture works. Okay. Yeah. It is a part of the old architecture. Yeah. Native thread, shadow thread, and JS thread. Again, those three threads remain the same. The only thing that is eliminated is this bridge. Instead of the bridge, we have something called JSI and stuff like that now. But yeah, the whole concept, everything else remains the same. Only this bridge is being replaced. Also, one more thing I think I should notice, this is uh, now synchronous instead of async, right? uh, Again, since you basically have that object exposed through JavaScript, this becomes synchronous. So this bridge was asynchronous, right? So instead of this is now synchronous. That's it. Is there any challenge with the new architecture? Like, not that I'm aware of as of now. Like, the new architecture is something I'm not very familiar with as well. So, even I need to read up. But as of now, it has very exciting stuff happening on it. So, to give you a hint, it's like I mentioned Hermes engine, right? So with Hermes engine, they are looking to statically type stuff so that you can basically improve the performance. Speed would be a problem as it's synchronous, I think. Not sure. I wouldn't like to comment on this. This is something like I'm not sure about. You want to explore it even. Yeah, you can build minor projects. Like if you know React, you can definitely try React Native in the snack as well, this Expo snack, so that you don't get into the setup. Okay, one more thing. Setting up with Expo is pretty simple. So with Expo setup, what you need to do is just run two commands. Like you can go to the Expo docs. Like if you go to the Expo docs, uh, you can see like quick start. You basically run this code. My app is the name of your app. Instead of this, you just basically update the name, cd into this folder and run npm. After that, everything is set up. Then you basically just need to download an Expo Go app from the Play Store and scan the QR code through that. So when you npm install, you would basically npm start run start. You would get a command. So you run the code. It gives you a QR code, and you just scan through that Expo Go app. So the Expo setup is pretty easy. This is something you can do on your own. React Native setup might take a bit of time. That is a bit complicated. Yeah. Uh, no, it's not companies are using old architecture, new architecture. This is basically what React Native version you're running on. If you're running on versions lower than 0.69, you're on the old architecture. And if you're on the basically, if you're on the new, if you're on versions above than 0.69, you're on the new architecture. So that's like what I mean by companies using old architecture and new architecture. Okay. Yeah, yeah, you can unmute yourself and ask question. Is simulator necessary? No, you need Expo Go app for running Expo projects. Yeah, the Ronak, you can unmute yourself, not an issue.
Yeah. Hi, Nancy. So
Hi.
the question that I have is, so unlike how in web we, for the login we use the JWT and then we, for every request we store it and then login has to happen basically every time, right? But in mobile apps we don't do that. Once you log in, it stays. So how does that happen and like can you explain me the architecture of the login basic persisting the login?
It's the same in basically your web as well as mobile. Like nothing is different over here. So in normal web, what you would do, you would basically, if you're using JWT, you get two tokens, an access token and a refresh token. So whenever the access token basically expires, you use the refresh token to get a new access token, right?
Yes.
And you store the refresh token somewhere, either local storage or HTTP only cookie or something like that, right? Correct. So
Yes.
you can do the same thing in the mobile as well. So you get an access token, you get a refresh token. You store that refresh token in React Native local storage or MMKV or something like that. So you basically get, if you search React Native local storage, you would get a lot of options. So this is like async storage. Like I think this is deprecated or something like that. But yeah, you can see this is removed. Use one of the community packages instead. So you can go and you can see a lot of what do you say, uh, local storage equivalent. So you can, I was saying about this, like MMKV storage. You can use this, right? Using JSON. So this uses the new architecture. You can see, right? Using
But
JSON.
the thing is, is that the right place to store? Because I want to know whether it can be compromised or not.
Whether it can be compromised or not, not sure.
Compromised is it a
Yeah,
safe place
I
to store
understood
it?
your question.
Yeah.
Like, I'm not sure about that. Like, I am not really into security a lot. Like, that is not the strongest part for me. So I do not know about that. But
Yes.
Usually people do store in local store.
And I have one more question.
Hmm.
Like you mentioned, you transitioned from a web developer to a React Native developer, right?
Hmm.
I'll tell you about myself. I'm working as a front-end lead in one of the MNCs. So here I've been working on React for 5 years now. So
Hmm.
I want to stick to React, but in terms of React Native or some next year, maybe something like that. Okay.
Hmm.
So that is the area that I'm exploring. But my problem is how do I make someone trust I can work on React Native as well apart from being a good React developer? Because see, one thing that we can do is we can build projects and gain trust. But see, projects again, you know what, the max that anyone can build is a recipe app or some other app which is a free API basically, right? Because you
Hmm.
wouldn't want to create an API, host it
Hmm.
somewhere, and then because it includes a lot of overhead. So in your case, I think you were lucky enough that you got a chance to make a transition. But in my case, it's not happening. So what can I do in this case?
I think Swapnil can answer that question better. Like, I'm not sure. I was lucky enough that my company basically did everything. It had web, it had React Native, it had a backend, it had GraphQL. So I got to explore everything. So yeah.
Basically,
Okay.
actually, the thing is, yeah, I reached my manager multiple times for making this switch, but he's not keen in doing that because he's saying, Ronak, you're working for a project which is helping me. Why I'm not interested in releasing you from my project and make you work under some other manager.
I'm not sure. Like, I'm not the right person to answer this question. Sorry.
Okay. Yeah, Swapnil has mentioned. Okay, I'll talk to.
Yeah, it's better if you ask Swapnil, man. Okay,
Okay.
yeah, difference between view and safe area view. So basically, what safe area view is, it's the same as view. The only difference is when you have mobiles, right, which have notches and stuff like that. So on the top you have some weird curvature and stuff like that. So when you render the view, you you may end up painting over that notch and stuff like that. So what safe area view does is it effectively makes sure you always render, you basically paint the screen only after all the notch and all the weird stuff is over. So your view will always be perfect. So that's what it means by safe area. So safe area basically, it's in a safe area where you can paint. With view you can paint even before like the notch is over and stuff like that. So it's just that difference, nothing else. Yeah, it's better to use safe area view, but I just showed you because I think that's a bit. It doesn't sound so scary as safe area view, but effectively it's the same. Safe area view just make sure you paint in a safe area. You don't paint over notches or some weird camera stuff and like that. Okay, any other question? How was your work? What you made there? And okay, sorry, what your personal belief? Um, how was my work? So again, like I have just recently switched. So this is like my first week in Bangalore. So in the new company, I haven't done much. Like I'm just setting up React Native projects. Like as I said, like that's the hardest part. So yeah, that's what I'm doing. In my previous company, I was working in an edtech startup. So there I built a lot of deep linking features, notifications, uh, over there updates and stuff like that for the mobile. Like around 10 to 15 screens as well. Like I think more than that. On quiz, like we had three apps, like teacher app, student app, admin app. So I worked on all of them. On some I worked on messages system. So that was done using GraphQL and Hasura. So like a lot of diverse stuff. Uh, yeah, yeah, can yeah, yeah. I'm sharing the slides now. I'll share it with Swapnil as well, so that whenever the recording goes on the YouTube video, he he will be able to link it. Um, Can you share the slides and then? Okay, and how are salaries and opportunities compared to React and web developers? Okay, not sure how are the salaries and opportunities for React Native compared to React Web. Not sure. Like recently, like during job switch, I was looking for a lot. Like I was looking at a lot of opportunities, but I got more responses from React Native side. That is something I have experienced. But apart from salaries and stuff, I don't think there's much difference. Not sure, like not the right person to ask. But yeah, I did get responses more from the React Native side. That is true. Okay. So I don't think any other questions are left. Will there be a next section? Yeah, actually, I was planning on keeping three sections, like three sessions. So this is like the first one. So with this, like you would be able to build small UIs like card and stuff like that, right? Then the second one, I'll go over what flat list, scroll view, section list, and stuff like that. So basically, you don't use map to loop over data in React Native because that is slow. So that is something I would cover in the next section if that happens. So when that happens, I'm not sure. But yeah, any channel you stop, uh, any channel like React Native, like honestly, I didn't find any good tutorial. This is something like I went through the docs, I read here and there. That's how I learned. So like I was directly given tasks like, hey, this screen needs to be linked. So this is a card. Make sure when the user clicks, he goes to this screen. So that's how I started React Native. I myself didn't find good resources for React Native as well. Like that is an issue, but I think Hitesh Chaudhary has one that may be good. I'm not sure, but apart from that, I couldn't see anything. There are many languages to create Android. Okay, there are many languages to create Android apps, and then what is the difference between native? Okay, yeah, one thing I think I forgot to mention. So React Native and Flutter, one more difference is there. So I think I mentioned this, but once again to reiterate, React Native uses the native platform itself. So in case of Android, it uses the Android platform to basically build everything. So JS controls the Android platform. JS controls the iOS platform, right, directly. So this is how React Native works. In Flutter, it doesn't work that way. So the Flutter is basically isolated in its own Flutter engine and stuff like that. So that is also one difference. So let's suppose there is a new feature in Android, right? So basically, what happens is someone would create a binding for it, a React Native binding, so that your React Native code can call that native code, and after that you can work like it'll work directly. You just need to create a binding. But in Flutter, let's suppose Android released a new feature. Now, what Flutter needs to do is implement the same feature in the engine because they are not using the native. What do you say? They're not using the native code, right? They are not using native operating system. So that is like one big difference. Yeah, yeah. I think we are quite late, so let's just stop this for now.